Hello dear students, welcome to That's It YouTube channel. I am KASU Sir. In every session on Monday, I'm going to discuss you the important topics related to JEE or NEET chemistry. The discussion here is not only confined to the theoretical part but also will enable you to apply these concepts onto the questions or numericals so that you can improve your score every time that you are attempting for the exam, whether that could be your college exams or your UTs or the board exams or the competitive examinations. So follow these sessions, watch the videos until the end. Please like, share, and if you are new to the channel, subscribe. So the topic that we are going to discuss today is the important one, as you all know, shielding or screening effect. Before I begin the session, I would like to tell you about the maintenance of the bodyguards by the celebrities, isn't it? So we all are aware of the fact that the celebrities or politicians, they maintain bodyguards, isn't it? So there are multi-layer bodyguards involved depending upon the kind of celebrity or the politician. If you have the PM, Prime Minister range candidate, certainly the guardsmanship is more than the normal celebrity. All right. So here, if I take a scenario where the politician or the celebrity is flanked or surrounded by various layers of the bodyguards, we could expect layer 1 bodyguards to be more in action or active than the remaining, isn't it? Like if you take our honorable prime minister case, you know that he will be closely guarded by the NSG, followed by the other layers of the security, isn't it? So we say that this layer, the first layer of security, is considered to be little stronger than the other layer. All right. Likewise, when you take the various electrons of different orbitals, you have come across the s, p, d, and f orbitals during your preparation, isn't it? You know that s orbitals, when it comes to the proximity with the nucleus, this is the nucleus that I'm talking about. When you talk about the proximity in a given main shell, obviously s orbital is little closer because it starts from the first orbit, isn't it? At the same time, the shape of s orbital being spherical without any node present, you know that you have studied in structure of atom that number of nodes over here in 1s is equal to 0. That means this orbital is having a periphery which fully covers the space around the nucleus. When it comes to the p orbital, it has acquired the dumbbell shape, double dumbbell, etc. All right, and then diffused shape of the f orbital. So as far as the shape is concerned, that occupies more periphery would be S. And proximity, the closeness with the nucleus is also more for the s orbital. That is the reason why you would expect the s orbital to show more shielding than the remaining orbitals, isn't it? So this is what we say, that as we move away, as we go away from the nucleus, all right, from the nucleus, the shielding effect or screening effect, one and the same, decreases, isn't it? All right. So if you look at this particular aspect in the context of what you call the nucleus and orbits around it, all right, you'll probably understand better. Now you see, there is a nucleus which is positively charged, all right, which is surrounded by various electrons in different orbits as well as orbitals, right? It could be present in s, p, d as well as f. All right. Okay. So you can see that if I'm talking about the force of attraction between the nucleus and this electron, this one, this is inherently dependent on how much these electrons, the other electrons, are going to protect this electron from the nuclear force of attraction. This is what I said. Alright. So the degree of protection by the inner electrons, degree of protection by the inner electrons on the valence electron from the nuclear force of attraction is what you call as shielding effect. Alright, what did I say? Degree of shielding or screening by the inner electrons, that is the bodyguards. Degree of screening by the electrons on outermost electrons, outermost electrons from the nuclear force is what you refer as the shielding or screening effect, which is said to be higher for the s orbital than the other orbitals. We say that d and f, they are age old orbitals. Naturally, we can expect their protecting power would be to be lesser in comparison to the NSGs, the top commandos. Alright. Okay. So these two orbitals show poor shielding effect. And this is going to impact the properties of the D and A block elements. Alright. And lower elements of a group. Lower elements of a group. So I want to explain this phenomena by taking certain properties into consideration. So now we need to understand what's happening here by taking up some of the examples. So one of such property is what you call as atomic radius. Look at the graph. Alright, you can see that if you look at the graph, there is a D block contraction, right? Talking about the group, you can see that boron, aluminum, gallium, indium, thallium, as one would expect that as we go down the group, the atomic radius to increase, what you call, isn't it? Atomic radius will increase. However, in certain element, there is a decrease in the atomic radius. This is what you refer as D block contraction. You're going to see that in the F orbital or F block elements also. Alright. So what happens here is when we enter the elements gallium, the D electron comes into picture. Alright. And you all know that relatively D electron shows the poor shielding effect. Okay, so what will happen here is like if you have a nucleus, we are talking about attractive forces between the nucleus and this electron, and there is a D orbital which is present over here. It is not able to protect the outermost orbital or electron from the clutches of the nucleus. So what will happen? The attractive forces will make the valence electrons to move towards the nucleus, and thus the size of the atom to shrink. So when the D and F orbital comes into picture, because of their ineffective shielding, we could anticipate the size to naturally decrease irrespective of the trend in a particular group or period. Hope you're following. So that's what is happening in case of what? Gallium. So actually gallium would have had more atomic radius than what you call the other elements which are following it, boron and aluminum, but unfortunately we found it to decrease. And similar phenomena, in fact more important phenomena, could be seen in the inner transition element, which will broadly affect its properties. This usually happen in inner transition element or F block. You can say as soon as you hear the term F block, you can say immediately that the shielding or screening effect is low. Alright. Now when we are talking about the ionic radius or even atomic radius versus atomic number graph, you see every time when I am increasing the atomic number, in the lanthanides or actinides, what is going to happen? The number of protons in the nucleus are increasing. So positive charge is increasing. As atomic number increase, the positive charge increases, isn't it? Positive increases. Alright. And there is what you call more attractive forces with the nucleus on the valence shell for the reason that the D and F electron that are present are not able to protect properly these valence shell electrons from the nuclear force of attraction. Hence, nucleus is able to pull the valence electron close to itself and decreasing the size every time. You can see for every increase in the atomic number, alright, the size decreases from lanthanum to lutetium. Same thing can be seen in actinides. Actinium to lawrencium, the similar trends are being found. So this is what you call as lanthanide contraction, because of which the sizes of the metal cations of lanthanides are much smaller, because of which they are usually covalent in nature. The compounds which are formed by the trivalent cation of a block element is usually covalent. Important, isn't it? So this is the most important phenomena that we study in F block elements or even periodic properties, right? You would have come across the what you call 11th just enter student or 12th ones who are studying F block elements, inner transition elements, might frequently face this topic, alright, in multiple occasions, D block, F block, etc. etc. Now, on this basis, let's also discuss about the ionization energy values. As you could see, as we go down the group, alright, as we go down the group, as you said, the atomic radius, what will happen to the atomic radius? Increases. Therefore, ionization energy should decrease. However, when you compare the last elements, you can see the last elements, they are almost similar. You can see there is a drastic decrease, alright, there is a drastic or rapid decrease in atomic radius, alright, sorry, ionization energy in the beginning, but that rapidity or drastic fall is not seen in the last few elements. Indeed, if you take third group or 13th group elements, the ionization energy, if you are comparing first ionization energy, smaller the greater. Boron, aluminium, gallium. It should be indium and thallium. However, it was found in reality the thallium has more ionization energy than indium. That's real. The reason is simple. In this case, the F block elements, alright, show poor shielding, alright. Therefore, nucleus will have more attraction on the valence electron. So it's not so easy to remove this electron. So ionization energy increases for thallium. Alright, so such type of abnormalities can be explained by using the screening effect or shielding effect. This is even later can be expanded to the stability of lower oxidation states down the group. Very important. So as we go down the group, the stability of the lower oxidation state increases. That means if you are talking about what you call the 14th group, the plus 4 oxidation state, if you take, is more stable for carbon, then silicon, and so on till lead. But if you take plus 2 oxidation state, it is greater for the lead. Alright? Sir, why? What's the reason behind it? It's very simple, beta. Now you see the nucleus, we are talking about the nucleus. We are talking about the electronic configuration of a 14th group element, NS2NP2, isn't it? Now when we talk about the shielding, you know that in case of lead, there is N minus 2 f orbital, as well as m minus 1 d orbitals, which are poor at shielding. So since the shielding shown by the d and f orbitals is weak, there is more attractive forces between nucleus and these two electrons. Hence, this becomes inert pair. That's the reason why it is able to lose only plus two, only two electrons. So that's the reason why, as you go down the group, the stability of the lower oxidation state increases. So such type of important concepts can be explained by using the shielding effect. Hope you understood. Hope you followed. Like the video, you know what to do, right? So that will help us a lot. All right. So please keep watching. That's it, YouTube channel. Keep endorsing the quality teaching. Take care. See you in the next video.